everyone, welcome back once again. So as we see earlier, we have completed this SOLID principles. So in this one, so in solid principle, we completed as single responsibility, open close principle, and list scope substitution principle. Now today's we are like studying about the interface segregation principle, that is stand for the ISP, and it is the fourth principle in the solid, and it is it teaches us a design small focus interface instead of one large interface that force class to implement method that don't need. Okay, first of all we have to answer what is ISP. Okay, so what is ISP? So like ISP, so definition wise we can say that a client should not be forced a client should not be forced to depend on one method they don't use. Okay, not depend on method they don't use. In simple word, we have to say that instead of a big interface, create a multiple smaller specific interface. Okay, a class should only implement methods that are relevant to it. Okay, so class should only implement methods that are relevant to it. Okay, so this is mean that what is ISP? So integration interface segregation principle. So real life analogy, we can say that it's look like, imagine you are applying for a driving license. Okay, suppose your application suppose the application form asks, can you drive a car, can you fly an airplane, can you sail the ship? So you want a car license, but you are forced to answer the question about plane and ship. So that a bad design. Okay, instead that there should be a separate license: car license, pilot license, and ship license. Okay, so each person choose only what they need. Okay, and what is exactly ISP? Interface segregation principle. This means instead of having a big interface, like instead of having this big interface, okay, we like create a multiple small interface. Okay, with a specific task, Okay, so understanding with the bad example. So let's see with the some bad example through we like understand this ISP. Okay, the first interface is that interface is worker. Okay, interface worker. So worker can it have a cook method, a deliver method, and the collect payment method. Okay, this interface said the worker must know cooking, delivering, and payment collection. Suppose we have a kitchen staff. So class that kitchen staff implement all this worker. Okay, so kitchen staff only cook. So but the interface that are implementing can do cooking, delivering, and payment collecting. So it can do like three things. Okay, cooking, delivering, and payment collection. So implementation become look like this thing. So class kitchen staff implement the worker. Okay, implement the worker. Override the property that is public void cook and the system dot out print ln cooking the food. And it also override the delivery thing. So like void public delivery, that is not applicable, and override the payment collection, that is not applicable for the cook. So these two methods, so we can say that this one method and two method are useless. So these two methods are become useless inside. Now consider a delivery partner. Now consider another example, that is delivery partner. Okay, so we want a delivery partner. So in the class the delivery partner which implemented all the feature of the worker. Okay, so like a delivery partner, so we can say a delivery person only deliver the food. Okay, but they are like we can say that a delivery person only deliver the food, but they are forced to implement cooking, delivering, and collecting the payment. This result become our code like this thing: class delivery partner which implement the worker class. Okay, worker class and override the property that is cooking. So that is not required for the this delivery partner. And this deliver the partner, so it like deliver the order. Okay, override the collect payment, that is not applicable. So again, the two unnecessary method we have in this this code. Okay, why it is bad? 1 second. Sorry for this like delay. So where we are? Oh, so we are discussing that we can see that this delivery boy having this it implement this worker class, and in which we have only one necessary thing that are required to be like a delivery boy. Okay, so the two other methods are like unnecessary and the rest. Okay, so why this is bad? Why this is considered as a bad? Because suppose later we want to add another method, that is void was utensil. So now every class implement now every class implementing the worker must add override public void was it utensil. Okay, so every class should have like doing this thing. Okay, so even if they never was the utensil, this make the maintenance difficulty. Okay, like this make the maintenance very difficult. Okay, so what is the better design for this one? So we have to like give this the better design for this one. So instead of one large interface, we split into the smaller interface. So how can we do? So we have cook interface. Okay, so interface cook have only cook cook all this thing. Okay, only cooking related method. Okay, delivery interface, like a delivery boy have an interface only pick up and deliver things. Okay, only two methods that are related to the delivery. Okay, and with the payment collector interface have to collect that payment. So only payment related method are needed for that payment class. Okay, and we move to the kitchen staff. So a class like kitchen staff which implementing the kitchen staff which are implementing this cook. Okay, so the class that are implementing the cook can override at the rate override public void only public void cook order. Okay, cook order and system of preparing the food. Only one method is required, and that is perfect. Okay, when delivery partner when a delivery partner we have, so in that case it implement the deliver class. Okay, the delivery partner implement deliver override the property that is pick up. If they pick up the pick, then will system dot out print dot ln, like this will print the like this order is picked. And another feature that is override is that is delivered, like delivered. So in that case it delivered things. Okay, no cooking method, no payment method is required. So whenever the cashier implement the payment collector at it can be like void collect. Okay, so only payment, nothing else. Now flow diagram look like this thing. Okay, so earlier we have like worker. Okay, one use interface who can cook, having the feature of delivery, payment, all this thing, and forced implementation happen. If I implement this worker. Okay, if I implement this worker, so in like is a package of subscription, we can get the delivery methods, the cook method, and the payment collection method. Okay, and if we have to like distribute in a small interface for the cook, the kitchen staff, for delivery we create a delivery partner, for payment collector we create a cashier. So each class implement only a interface that is actually needed. Okay, so each class implement only the interface that is actually needed. Okay, so let's see a real life example. Real life example is smart devices. Okay, so smart devices, suppose we design like smart devices, so interface smart devices. Okay, void call. Okay, and void a smart device that can call, then take photo and then print. Okay, now consider a smartphone. We need like call and camera feature. Doesn't don't need like a printing feature. Okay, in the smart feature, if I implement the feature, the printing feature is unnecessary added in the smartphone. Okay, and in printing, if I want a printer, so in that case we print that what a print does not need a call feature and a camera feature. Okay, so bad design mean like bad design force every devices to implement everything. Okay, like interface callable to call, interface camera to take photo, interface printable to print. Okay, these are the like better design as compared to this one. Everyone. So now smartphone have the callable method and the camera method, and the printer have only printable methods. That's one of the perfect. So what is the benefit of the ISP, the integration segregation principle? So integration segregation principle mean that we have a cleaner interface. Each interface have only one purpose, like same as like SRP single responsibility principle. Okay. So easier for maintenance, avoid a new method. So avoid like adding a new adding a new method to cook only affect the cooking things. So delivery class remain unchanged. Okay. Better reusability, different class can implement different combination of interface. Less dummy code, no more like override like cook, that is not applicable. Okay. Easier for testing, so each interface can be mocked and tested independently. So like many of one like confused with this like single responsibility principle and ISP principle as like same. Okay. So many students confuse these two. Okay. So apply to class and it applied to interface. Okay. So SRP applied to class, whereas this apply for the interface. So one class should have one responsibility and one interface should have one responsibility. Split the large classes and it split the interface. Okay, these are the differences. Only difference is class and interface. So think of this way: SRP like don't make one class to do many jobs. Okay, and ISP don't make one interface declare many unrelated methods. Okay, so interview tips is here. And if the interviewer asks, explain the interface segregation principle, the strong answer is that interface segregation principle start that the client should not be forced depend on a method they don't use. Okay. So client state, like we can say that the client should not be forced. A client should not be forced on the method they don't use. Okay. So instead of creating a one large interface with many unrelated method, okay, we should create a small, like multiple small focus interface in this, like in the restaurant example, like kitchen staff member only need cooking method, a delivery partner only need delivery methods, okay, and the cashier only need payment methods. So this avoid the unnecessary implementation and reducing the coupling and making a code easier for maintain and extend. Okay, so this is all about aggregation. This is all about the interface aggregation principle. Now move to the last principle, that is D. D stands for this stands for the dependency inversion principle. Is the last principle of the solid and one of the most important concept of the LLD. And it is also a foundation for the dependency injection, make a useful for the like framework like Spring Boot. Okay. So what is DIP? Dependency inversion principle. So by definition we can say that so a high level module should only depend. High level module should only, so like underline, high level module should only should depend on low level module. Both should not depend on the abstraction. Okay. So abstraction should not depend on detail. Detail should depend on the abstraction. In simple one, depend on interface, not on the concrete class. Let's see with some example. First, we have to understand what we are talking about, the high level versus low level module. Okay. So high level and the low level modules. Okay. Suppose you are building an e-commerce application. Okay. So what are the high level modules? So let's define what are the high level modules. The business logic look like order the services. So it is a responsibility to create the order, validate the order, and process the payment. Okay. And it does not care how the payment actually processed. Okay. So this is the high level model. Like if have business logic having the order services, in that we are creating the order, okay, validating the order and processing the payment, okay. So we don't care about the how the payment actually process, like we don't know, okay. And when we are talking to the low level module, so when we're talking about the low level module, in that actual implementation thing, okay. For example, so payment will be done by this Stripe payment gateway method, or Razor payment gateway method, or PayPal gateway method, and these know how to charge the customer on the basis. So the implementation thing happen here, okay. So what is the bad design? So like bad design, so class, we have a class that is order services, in which a private final strip payment, like a strip payment gateway, Stripe payment gateway, we know right as a gateway, okay, that we call a new Stripe payment gateway. So look like this one, look like simple, but there is a hidden problem, okay. So dependency diagram. So order services depend on the Stripe gateway, but order services directly depend on the Stripe, okay. Suppose tomorrow your company stop using Stripe and use Razorpay, you should you must modify, and now again the order order services again again letter to the PayPal and modify again to the Square, okay. So modify again. So every payment gateway change force the change in business logic. So that violated the DIP, the dependency inversion principle. The problem is that tightly coupled things, okay. So tightly coupled thing that order services is depend on the Stripe. Only Stripe works, okay. So hard to change the payment gateway. So now to edit the business logic, okay. Hard to the first of all, the first problem is that in this one is that it is tightly coupled. Second is that hard to change the payment gateway. Need to edit the business logic, okay. And hard to test, okay. Suppose the Stripe server is down. Suppose Stripe server is down. You cannot easily test the order services, okay. So better design is that to create the abstraction, okay. So we have like this class order services. Now we have to use abstraction in that case interface. So like interface payment gateway, okay, payment gateway and payment result, like payment gateway payment result, that is charge, okay. So payment gateway request, okay. So now the every payment gateway implement this interface, okay. Now every payment gateway implement this interface should be implement. So now if I using this Stripe, so class Stripe gateway implement the, okay, payment gateway, okay, and gateway override the payment result charge requested, and in that we have to like system.out.print.ln using using strip, okay, Stripe return the payment result dot success, okay. And if we want a Razor Pay implementation, then we again write class Razor Pay implements like payment, and then override that methods, and we have to return this logic, okay. Again for the PayPal also implement this payment gateway and override that method, and this will result. So now the order services, instead of depending on this Stripe, depending on the interface, okay. So how the order, how look like. So class order services, we have private final payment gateway, like this is payment gateway, that is known as like created object, that is payment gateway. So in this public order services, we passes the payment gateway, this payment gateway implies that this payment gateway, so like public void, so public void place order, so public void place order, so like payment dot payment gateway dot charge that request, okay. So like notice something important. There is no importance of this type. We are not dependent on this type. We are dependent on the logics. Okay. So no razor pay, no PayPal. Only the payment gateway methods. Okay. So this is what is DIP. So how the object creation happen? Suppose today we want like Stripe. So in that case, we write a payment gateway. So new Stripe payment gateway. Okay. So like so order services. So like order services. Okay. So new order services, in this we have to add this object. Okay. So created the Stripe object and we put inside this one. Okay. Tomorrow we want a this different razor pay. Okay, so how this object creation happen? Tomorrow we need like a like razor payment, so we write a payment razor pay payment gateway. So in that case, we put this inside this order services. Notice did you like modify the order services? No, I don't modify the order services. We only change the implementation and past. We change this implementation and this past. Okay. So what is the workflow look like? So workflow look like this way. So we have order services. So we have payment gateway interface. Okay. So if we need like Stripe, so we go to this one. If we need Razorpay, so we go to this one. And if we go to payment. So order services only know about the interface. Okay. So this is know about only this interface. It does not care about the implementation and is used. Like how don't care which implementation is used. Okay. And why constructor injection? Why constructor injection is there? Like we have a public services. Inside this we have payment gateway things, and this payment gateway is look like this one. So why we use this constructor? Okay. So this is called a constructor injection. Instead of creating a dependency inside the class, someone else provided them. Okay. Instead of creating a dependency inside of the class, so this is not dependency injection. Okay. So real life analogy, like imagine a car, imagine a person charging a phone, and phone has a charging port. Okay. Instead, so it does not care about whether whether the electricity come from like Samsung charger or about the Apple charger, like power bank or the laptop USB. Okay. It only needed a compatible charger. Okay. The charging port act as an interface. Different charger are the implementation thing. Different charger implementation. The phone depend on the abstraction, not on the specific charger. Okay. The phone depend on the abstraction, not on the charger. Okay. So why is DIP useful? So like for why DIP is useful? So first of all, easy to replace the implementation. Okay. So today we are used Stripe, tomorrow we reserve. So no need no need to change in the business logic. Easier for testing, like create a fake implementation like class fake payment, implement the payment gateway, override payment charge, that is result success. Okay. So now test the don't contact the real payment gateway. Okay. Loose coupled, instead of like order depend like tight couple, like order services depend on this type. Now we become to a payment gateway method. Okay. So it become a loosely coupled. Okay. Changing a stripe does not affect the order services. Okay. Better scalability. So adding another payment method only require a new implementation. Existing business remains same. So you notice something, it is like simpler, simply like a OCP, like open close principle. We are like open for the extension, but close for the modification. Okay. So, but many of the people confuse about it with the less DIP, with DIP and OCP. Okay. So how does it look like? Many students with the OCP, that is open close principle, and DIP like dependency inversion principle. So open for extension. So in that case, we know that open for extension and close for modification. And in this, depend on the abstraction, not on the concrete classes. Okay. Abstraction. Add new functionality without changing the existing old code. Reduce the coupling using interface. Focus on extending behavior. Focus on managing the dependencies. Okay. So relationship, we can say that DIP often achieve OCP, because order services depend on the payment gateway interface, you can add new payment like Stripe, Razorpay, PayPal without modifying the order services. Okay. So we have studied the all solid principle and we have to see a one-liner summary for the each one. So like we have solid, like we have a summary. So S stand for the single responsibility principle, one class, one responsibility. O stand for the OCP, extend behavior without modifying the existing code. Okay. L is list scope substitution principle. A subclass should be usable whenever its parent is expected. Like I am expecting that this class give me this result, so it will. Okay. Then ISP, so ISP integration segregation principle, interface segregation principle. Create small focus interface instead of a large interface. Okay. And a DIP, that is a dependency inverse principle, depend on the interface abstraction, not on the concrete implementation. Okay. So I am focused on not on the concrete implementation. So what is the interview tip for this DIP? For DIP, we can say that we have to answer, explain the dependency inversion principle. So strong dependency inversion principle state that the high level module should depend on the abstraction rather than on concrete implementation. So high level modules depend on the high level module depend on the abstraction rather than the concrete implementation. For example, we have order services should depend on the payment gateway interface instead of creating a Stripe gateway. This allow to switch between the Stripe, Razorpay, PayPal, or even a mock implementation for testing without changing the business logic. So it can promote a loose coupling and improve the testability and make the system easier to maintain and extend. Okay. So this is all about solid principle. Okay. So we understand what is and meaning and with the example. Okay. So definition clear, example clear, and full what how to do. Okay. So in further lecture we like try to visualize and write a sample code to understand in better way. Okay. Thank you.